So today we'll discuss data science life cycle. I shared you one PPT yesterday after the class. I've shared. I
Yes,
think
sir.
so. Yeah.
Yes, sir.
Can you see my screen now?
Yes,
Yes,
sir.
sir.
Yes, sir.
So this is over. Introduction to data science. And this stops. Already I've done with this. What is data? Data can be structured or unstructured that comes in various forms like your text, images, numbers. So after the life cycle, we'll discuss some analytics stuffs, types of analytics and that. Importance of data science. It plays a crucial role in various industry by enhancing the decision-making processes through data-driven insights. Then business leverage data science to improve operational efficiency, customer satisfaction, and overall profitability. And as the volume of data continues to grow exponentially, the demand for data science skills is increasingly significantly. Then the data science process consists of several key data collection, although all those stuff should be discussed today. And machine learning, types of machine learning I have discussed. Supervised, unsupervised.
Yes, sir.
Yes, sir.
Thank you. Thank you. And what are the types of clustering? What is parameter optimization? Means your downs index, allowed coefficient, all those stuff that I discussed in the last class. I think yes. Yes. Yes or no?
No, sir. Clustering is not being discussed.
No, no, no. The types of overall I told you, na.
Yes, sir. Basically, introduction is here.
Means how types of clustering when we're talking about hierarchical
Yes,
clustering.
yes.
Yes, all those stuff we have already discussed. Yes, bolo. Discuss na.
Yes,
Am I
sir.
audible?
Yes, sir. Yes, sir. Yes, sir.
So, means when we are discussing the types of clustering, there are four types of clustering that I told you: centered based distribution, density, hierarchical clustering. I told you regarding that, but when we'll be discussing this in the third week, I think. Yeah. So there we'll understand the stuff. Okay. So in the next week, we'll be doing roadmap, EDA, imputation, normalization, outlier detection, then project discussion to be done in the next week. And project discussion first we'll do, and then Weka tool to be discussed also. Right, all of you? Then optimization, gradient descent, hyperparameter tuning, cross validation, data analysis, visualization. Then we'll go for supervised learning. Okay, and the algorithms, mathematics, unsupervised learning, then reinforcement learning, predictive NLP, text processing, deep learning, LSTM, all those stuff. Okay. So
Okay, sir.
without further ado, we'll start. When you're talking about the life cycle, so data science life cycle is a structured approach that guides the data scientist and ML engineer in extracting the insights and building data-driven solution. And the consists of several pieces like your problem definition and business understanding. Means before dividing the mm, uh, means before you come to a project, first you need to understand the problem statement, right? Means it's crucial to understand the business problem, define the clear objectives that what you are going to do. Means that includes identifying the problem statement, understanding the business goals and constraints, then defining the key performance indicators, that is KPI, then setting the expectation for the final outcome. Suppose giving an example, suppose a bank wants to detect the fraudulent transactions, means the goal is to develop a model that can classify the transactions as fraudulent or legitimate. Then the next step comes, then the next step is a data collection. Means effective data collection is the next step after problem identification, and is a step in data science process and involves gathering relevant data from various sources. Means gathering the relevant data from various sources means from SQL, from databases like SQL, NoSQL, from APIs like your third-party or internal services, from web scraping for online data, from IoT devices and sensors, surveys and customer feedback. Means in this step, we are means mainly data engineers help to set up the pipeline for continuous data collection. Means suppose the bank collects transaction history, user details, timestamp, and locations of the transaction from the available database. Then the next step is your data pre-processing and cleaning. What is data pre-processing and cleaning? In this step, uh, means the raw data is often incomplete, inconsistent, or it contains some errors, right? Means your cleaning and processing involves first handling the missing values like imputation, deletion, then remove the duplicate record, fix the inconsistent formatting, outlier detection and technique, data transformation, all those stuff comes into picture. Okay. When it comes to data, uh, so when to discuss this? Mm, should we discuss? Okay, guys. Imputation, outlier detection, normalization, standardization, those stuff you want to discuss now, or when we will discuss EDA, we'll discuss those stuff. Yeah, tell me. Outlier detection, normalization, standardization to be discussed afterwards. But I think outlier detection and because these terms comes now in data processing, and so we should discuss this right now, right? Yes or no? All of you, tell me.
Yes, sir.
Hmm. So we'll do imputation now, then your outlier detection technique. Mm, good to do. Complete this. Mm, analytics. Mm, okay, in the next class. Okay. Got it, everyone? Done. So when we're talking about imputation, what is imputation? I think Python. After discussing Python for data science, we should, if we'll discuss those stuff, then we can understand it better. I think so. I don't know about you.
Yeah, hello.
Yes, tell me. What up?
Yeah, actually, I have an opinion in imputation. Yeah, so can you correct me if I'm wrong. basically, the process of imputation is filling the null values using the mean, median, and mode by
Mhm,
calculating mean, median, mode and of the feature values. Am I correct
mhm.
or not?
Yeah.
Okay.
So I think
Sir, I think we will discuss after the Python.
yeah, that will be better way. I can understand. Uh, that will be better for us. Yes. Because before that, if you are from non-technical background, we cannot understand these stuffs. Okay, and then let me discuss the life cycle today and analytics types. Then in the next class, we'll do this Python for data science ML, then imputation method, outlier detection technique, all those stuff. Okay, getting it? EDA roadmap, project discussion, Veka 2, three classes. Mm, okay. What to do? Tell me. According to your preferences, we'll discuss. Tell me, quick, quick, quick. Don't waste the time, please, guys. Tell me. Okay. After the life cycle, today I'll discuss then Python for data science and ML. Okay. So, when you're talking about your first step, the means after data collection, all of you listen to me carefully now. We'll go in faster. So, means after data collection, when it comes to data pre-processing and cleaning, handling missing values like imputation, deletion, removing the duplicate record, fixing the inconsistent formatting like dates, currencies, text, then outlier detection and technique, data transformation, that is scaling and coding categorical variables. Suppose if a customer A's data is missing values, then how to fill the means using median or mean of the data set. We'll be using that. Okay. Then the fourth step will be exploratory data analysis. Means in this step it involves handling missing values, removing duplicates, all those stuff comes into picture. Um, because I'm thinking to discuss those topics right now. Because whenever you get the time, we should discuss those topics. What say? Tell me. Because in this step you can understand the processes. So that I'm saying. And so we can discuss this mathematics for data science and ML later on, but I'll tell you in details also. But in life cycle when it comes, so we're supposed to discuss these topics. Right. So all of you now listen to me very carefully. When I'm talking about imputation, so all are ready, right? No question asked for this. Let me open. Yes, tell me. Yes, tell me.
Yes, sir, we are ready.
Yeah. Mm. So when you're talking about your imputation, what is imputation? It is the process of filling in the values in a data set to maintain the data integrity and to improve the model performance. Everyone is there or not? Let me see first. All are there. All are active.
Yes,
Okay.
sir.
Yes, sir.
Yeah, we are good.
Please turn
Yes,
off your
sir.
camera, buddy. Who is that? Amit, can you hear me?
Yes, sir.
Hmm. So imputation means it is process of. So let me open my Colab so that you can understand. Okay. Means imputation is the process of filling a value in a data set to maintain the data integrity and to improve the model performance. Means missing data can arise due to various reasons, right? Why you are performing this technique? Missing data can be arise due to various reasons like your data entry errors, sensor failures, or incomplete records. And proper imputation ensures that the model remains accurate and unbiased. When I talk about types of missing data, before performing the imputation, it is important to understand the type of missing data. Like your MCAR. MCAR means missing completely at random. Means no specific pattern will be there and the missing values occur randomly at that point. Means suppose a survey respondent skip a question by mistake, then you can that can be said as MCR, missing completely at random. And missing at random means MAR means missing values depend on observed variables but not on the missing ones. And so customers with lower income tend to skip the providing their spending habit. Then one term is MNAR. What is MNAR? MNAR is nothing but the missing values have a systematic patterns related to missing data itself. Example, you can tell that people with higher salaries may avoid disclosing their income in a survey. What are the various imputation technique? First one is deletion method. Deletion method or least wise means in deletion method, first one is least wise deletion means remove the rows with the missing values. Means that is suitable if missing values are MCR or the data set is very large. But the disadvantage is least wise deletion, where it can remove the rows with missing values. Means it can lead to data loss and bias if missing values are not in random. What is pairwise deletion? Pairwise deletion means uses all variable data for each analysis rather than removing the entire rows, and it is useful for correlation or regression analysis but can lead to inconsistencies. Okay, then this is all about your deletion method, like your listwise deletion or pairwise deletion. Then there is simple imputation technique like mean imputation, median imputation, and mode imputation. These are most important and we are using this frequently. What is mean imputation? What is median imputation? Mean imputation means it replaces the missing value with the mean of the column and is suitable for the numerical data with normal distribution. But the disadvantage is it can reduce the variance and distort the relationships. Okay. How to perform mean imputation? I'll tell you right now. Then what is median imputation? Median imputation is nothing but it uses the median value instead of the mean. Means it works well for the skewed data like your income, house price data, all those size, it's working fine. Then what is mode imputation? That is most frequent values we are using. Means it is suitable for mainly categorical variables. Suppose we are replacing the missing city name with the most frequent city, then we are using mode imputation. How to use that one? Mean imputation, suppose the age is not there. This is the missing value and you have to use the mean imputation. Fast SQL simple imputer, non-PSNP, pandas SPD, data frame, then imputer, simple imputer you are using, and strategy is the mean imputation. Yes, imputed at free transform. So here it will calculate the mean of these two positions. Then the mean is the 12.2. So it will be replaced. Right? Getting it simple. Very simple. That's why I told you to discuss. Getting it, all of you?
Yes, sir.
Yeah.
Uh,
Yeah. Means like this, you can use your mode imputation or median imputation. Means suppose imputer is equal to simple imputer. Here the strategy should be median and imputer the free transform is here same, and in mode this will be mode. Getting it? Mode means the strategy should be most frequent. Okay, getting it?
Getting it, sir.
Sir, just a second, let me do it for you. Simple imputer, suppose median. Median, then suppose mode will be there. For mode, we'll be doing mode, sorry, most frequent. Getting it, everyone? This is mean, this
Yes,
is
sir.
median, this is mode. So there is some advanced imputation techniques like your k nearest neighbor imputation. Means it predicts the missing values using the nearest neighbor. Means most accurate, but it is computationally expensive. Suppose we'll be doing this. Just for suppose this example we take into consideration. Um, KNN imputation. What is KNN imputation? Suppose, and here we'll be doing from a scalar dot impute import KNN imputer. Okay, then here it will be a simple not simple using imputer is equal to KNN imputer, and the strategy will be n neighbors. Yes, neighbors is equal suppose 3. Then imputer transform. Yeah, just run this. Hmm, what's the error? KNN imputer. What is the error? KNN imputer strategy. Oh, sorry. Then let's leave the strategy. N neighbors. Sorry. Yes, now getting it, all of you. How KNN imputer works? Means it predicts the missing value using the nearest neighbor, that we have given 3, and more accurate, but it is expensive for large amount of data set. Then what is regression imputation? It uses regression model to predict the missing values based on the feature, like you're predicting the missing salary values using age and job type, right? Means you can import a linear regression over there, and you can use the imputation. Then multiple imputation, like a MIC, that is multiple imputation by changed equation. Means it creates multiple possible values for each missing value and averages them, and it reduces the bias and maintenance variance. Okay, but then there is a technique called deep learning imputation, like your autoencoders. It uses neural network to fill in missing values, and it is suitable for large amount of data set with relationships. Getting it? What is imputation? All of you.
Yes, sir.
Yeah.
Yes.
Yes, sir.
And suppose few missing values in a large data set are there, you can use mean, median, or mode imputation. For skewed numerical data, you can use median imputation. For categorical variable, you can use mode imputation. For non-random missing values, you can use regression or MIC imputation, multiple imputation there is. Then for complex or pattern in missing data, you can use deep learning imputation, MIC imputation, or KNN imputation. Means imputation is important for handling missing data effectively, and the choice of technique depends on the type, distribution, and the missing data pattern. The advanced methods like KNN, imputation, MIC, and deep learning can provide more accurate imputation, but it requires computational resources. Getting it? Yes.
Sir, is imputation is only for a single missing value or multiple missing values?
Well, yes. To remove means to fill the values, use this. Means imputation is that I told you. Means the main objective of imputation is to filling the missing value in a data set to maintain the integrity and to improve the model performance at the same time. Getting it? Then
Yes,
there
sir.
is a technique. Yeah. Then there is a technique that we are going to discuss it now. There is a technique called for when it comes to data cleaning and preparation. There is a technique called outlier detection. What to detect the outliers in a data set? So now say this outlier detection technique. Outliers are the data points mainly those that significantly deviate from the overall patterns. Okay, all of you. Yes, means outliers are the data points that are. Can you hear me properly?
Yes, sir.
Yes.
Means outliers are the data points that are significantly deviate from the overall patterns of a dataset, and they can arise due to errors, variability, or rare events. Means detecting and handling the outlier is important for improving the data quality and model accuracy. Okay, means why we're detecting the outlier? To improve the model performance. Means the machine learning models are sensitive to extreme values, and to enhance the data quality means identifying the errors and anomalies improve the decision making. Then we are using to detect the fraud and anomalies. We are detecting the outliers in financial transaction. Outlets means they may detect the fraudulent transaction or something like that. Then what are the common outlier detection techniques? There are three techniques mainly. There's two techniques. One is visual method, another is statistical method. Visual method we are using box plot that shows the quartiles and outlier. We can use scatter plot means that helps to visualize the unusual data points. Then we can use histogram that identify the skewness and the extreme values in the data point. It's an example about matplotlib, SPLT, C1, data then how to use the box plot. You can see over there. So you can copy this and run over here. Yeah. Yes, can you see that? This is the box plot that represents the outlet. Yeah. The 100 is the outlet. So it is David. Right? All of you? All of you, can you see this?
Yes, sir.
Yes, sir.
Yes, sir.
Means this is the
Yes.
visual method. And so you can tell it as the visual method. It's your box plot. Yes. Then There is statistical method. That is most important term. When it comes to the statistical method, means the first one is Z score, means the standard score method. It measures how far a data point is from the mean in terms of standard deviation. The formula is a Z score. Z is equal to x minus mu upon alpha, where x is the data point. Fine. X is nothing but the data point. Then your mu is equal to your mean of the data set. Then your alpha is equal to your Can you hear me, all of you? Due to network connection, I just left the call. Sorry for that.
Yes, just now you know.
Audible.
When you're talking about this, it means when you're talking about your statistical method, the first one, this is the standard deviation. Mu is the alpha is the standard deviation. Typically, the data point to Z score greater than 3 are considered as the outlier. Okay. Then, how to remove the outlier in Z score? Just see this, all of you. Can you see my screen?
Yes,
Thank you. So this is suppose we are importing a data frame and we are creating our own data set 5, 7, 8, 12, 14, 15 and up to 100. And then we are defining the visual period data frame, then data the columns of values, then z score value we have taken, and the outlier for outlier is the absolute value which is greater than 3, that is outlier, and that should be removed. Then it will calculate the Z score for each value. Z score by the formula is your x minus mu upon alpha. Oh, sorry, x minus mu upon alpha. Then the Z score is more than 3 will be the outlier. So here the Z score is more than 3. So 100 is the outlier in the data set. Getting it? All of you? How to declare the outlier in Z score? Means it works well for normally distributed data, which is Z score, and it is simple and easy to implement, but it is not effective for skewed and non-Gaussian data, and is sensitive to the dataset size. Means works best for the large amount of dataset, not the smaller one. Then the next technique, that is the IQR, means the interquartile range. IQR to detect the outlier, interquartile range means it uses quartiles to detect the outlier. Okay, the formula for IQR means it is IQR is equal to Q3 minus Q1, where Q3 is the third quartile and Q1 is the first quartile. All of you all are listening to me. These are important things.
Yes,
So
sir.
guys, please listen to me
sir.
carefully. And yeah, so IQR interquartile range, that means formula is Q3 minus Q1, means the lower bound is Q1 minus 1.5 into IQR, and the upper bound formula is Q3 plus 1 plus 1.5 into IQR. Okay. First quartile means 25% of the data, third quartile means 75, more than 75. Suppose the data set is this previous one. Q1 is here 25, above 25 percentile means 12. Q3 is 75 percentile above. That comes to 30, around 30. So how to calculate the IQR? IQR formula is Q3 minus Q1. And 30 minus 12 is 18. Q3 minus Q1, 18. Then we need to calculate the lower bound or upper bound. Lower bound formula Q1 minus 1.5 into IQR. What does means Q1 minus 1.5 into IQR means Q1 is, what is Q1? 12 minus 1.5 into IQR. We found it at 18. Then 12 minus 27, it is minus 15. Then we have to calculate the upper bound. Upper bound formula is Q3 plus 1.5 into IQR means 30. Your Q3 plus 1.5 into IQR, we got it as 18. 30 plus 27, that is comes around 57. Means from lower bound or the upper bound, we can find as the means lower bound we are calculating because the value below the lower bound, it is called as an outlier. But here there is nothing below lower bound, so there is no outlier in the lower bound. So the value above the upper bound, that is called outlier. So outlier value is upper bound value is 57. So the value above 57 means above upper bound is your 100, right? So this is an outlier. Getting it, everyone? How to implement it? Just see.
Yes, sir.
Q1, quantile Q1 is 0.5, Q3 is 0.75, IQR formula. Then what is called outlier? Here, remove how to remove it if the value is greater than equal to the lower, less than equal to the lower bound, or greater than equal to the upper bound. Getting it? Getting it, all of you? Well, this is lower bound, this is upper bound. So above upper bound it is outlier, and below lower bound it is outlier. Getting it, everyone?
Yes,
Tell
sir.
me.
Yes.
Yeah, thank you. I think there's some error removing the outlier. So what will happen? Suppose the column name will be there. No, there is some error, right? Suppose we are defining Q1 as the just see this, all of you. This is value, one tile given, yes. How to remove the outlier? So I have to declare it here. I have to do that, but and it's not that important, I think. Okay. So suppose we are giving lower bound is equal to q1 minus 1. So sorry guys, due to internet connection happening. Can you hear me? Hello, can you hear me?
Yes, sir. Yes, sir.
Sorry guys. Extremely sorry. What is happening? So okay. So we are doing this. Can you see my screen? So lower bound I have declared. So value v for lower bound.
No, your screen is not visible.
हाँ भाई
Yeah, now
बोलो
it's visible.
what up?
Now it's visible. So
And it is upper. Then you can find the outlier. Now you got it, everyone. In this way, we can detect the outliers. Means this is value, obviously. means it well for the wish most robust and compared score. For large, small data, the threshold value have in IQR may not work also. Since we did Z score can work for works well work well for the skewed model. Since the Z score is invalid, but IQR is most robust. Standard deviation, but IQR uses quartile. Getting it. Having said that, let's continue our discussion. The means skewed or not analysis. Can you hear me? Yeah, tell me. Hello.
Now
Am I
you are
audible?
audible, sir.
Am I audible? I was not audible previously. Can you hear me, all of you?
Yes, sir.
Now you
Yeah,
are
now you are
audible.
audible.
Uh,
Previously, your voice was
so
connected.
the next step is your. Yeah. Now you can hear me.
Yes, sir.
So the next step is after data cleaning and preparation, the expert data analysis means it helps to identify the patterns, correlation, and analyze the data. We'll discuss this later on. Means there's come descriptive statistics, mean, median, mode, standard deviation, data visualization techniques, the histogram, scatter plot, heat maps, correlation analysis, means how to find correlation, how to create transaction. Yes,
Yes. Yes, sir.
my voice working.
Yes, sir.
What can I do? Hello.
Yes, sir.
Can you hear me now?
Yes, sir.
My voice is clear, crystal clear. My voice is clear, right?
Right, sir.
Yeah. So in means after explorated data analysis, means here after this step, we can discuss it in detail in the upcoming session. Feature selection and feature engineering means selecting the right features improve the model performance. Feature selection means removing the irrelevant or redundant features, and feature engineering means creating new features based on the domain knowledge. Means instead of using a raw transaction timestamp, we can extract hours of the day to detect the unusual transaction types. Then the next step will be your model selection, model building and training. Means in this step, machine learning or deep learning models are built using different algorithms like your supervised, unsupervised, deep learning, neural networks, CNN, and RNNs, ensemble method like your random forest gradient boosting. Means in fraud detection, we might use a logistic regression model for binary classification, like this example. Then model evaluation and after model selection, it comes to model training. Model training process using the machine learning analysis to make predictions that then uh, in model training we are training the models like uh, by giving the epoch size, by giving the timestamp, random state, train test split. We are just training the data set. Then after that, model evaluation, model training and a model evaluation. Then here, evaluating the model performance using accuracy, precision, recall, and F1 score for classification. R square, root mean square error, mean absolute error for regression. Then confusion matrix for classification. ROC curve for imbalanced data sets. So in the next class, what we'll be discussing first, your Python for data science, data analytics. Then the stops like accuracy, precision, recall. So when we will discuss the EDA, there I'll tell you accuracy, precision, recall, F1 score, R square, root mean square error, mean absolute error, confusion matrix, mean, median, mode, all those stops to be discussed. So remember from now onwards what we discussed. Okay, then hyperparameter tuning is there, cross validation, all those stuff. So after this step, model deployment means model after model evaluation, model deployment like uh, means the model means deploy the trend model into production for real-time batch predictions like your web API using fast API or Django, then cloud deployment like AWS, GCP, and Azure, then edge deployment for IoT devices like this. Then you need to monitor and maintain business insight. Means overall data science lifecycle is an iterative process. Means model must be refined, updated, and continuously improved based on the new data and the business needs. Getting it, everyone? So having said that, let's wind up the class for today. I do have another class right now, so have to wind up, and I'll share everything along with all of you. Okay? Getting it, everyone? Thank you. So you may leave now. You may leave the call now, all of you. And remember what I told you to discuss in the next class.